This example will demonstrate needing to use two different z-scores in order to find the area requirement. This example was taken from our class worksheet. It is problem number 7. In order to fit into a Russian Soyuz spacecraft, an astronaut must have a height between 64.5 inches and 72 inches. What percentage of women meet that requirement? If you will recall that at the top of our classroom worksheet, we were told that women's heights are distributed like a normal distribution with a mean of 63.6 and a standard deviation of 2.5. So the first thing we're going to do is put our notation at the top of the curve, so we have that handy for the rest of the problem. After drawing a normal curve shape, I'm going to put my z-scores in, my standardized scale. And then below, I'm going to put my X scale. This will allow me to double check myself as I'm doing the problem. We can use the program normal distribution in our calculators to find the rest of the scale if you wish. And to use this program, you choose the program. It asks for the mean, which was 63.6, and the standard deviation, which was 2.5 inches. Hit enter. It gives you the 7 different standard deviations from the mean. And if you go back to your calculator then and press enter, it will stop the loop in the calculator so you can continue using it as normal. So we have 56.1, 58.6, 61.1, 63.6, 66.1, 68.6, and 71.1 inches for our X scale. We are looking for women between the heights of 64.5 inches and 72 inches. So to take a look at that, I'm going to draw lines. I'm going to put my first line at where I think approximately 64.5 inches will be. And my second line at where I think the 72 inches, approximately where I think that would be. Those are both X values. I will call them X1 and X2. I can make a guess at my Z values. The first Z value will be between 0 and 1, so it will be 0 point something. And the second Z value should be 3 point something. Not quite at 4 if we have 2.5 as a standard deviation. So the next one here at 4, if we add on 2.5, that would be 73.6. So I'm going to make this 3 point something. And what I am looking for is the area between the two curves, which would be this area all the way to here. And I'm encouraging you to use your empirical rule or golden rule sheet to take a guess at approximately how much this area is. And at 1 standard deviations, that would be 16% over. So my guess is that I'm going to be bigger than 16%. I'm also quite confident that I am under 50% because that would be right in the middle of our curve. Okay, the next step is to set up my notation sentence. The probability that 64.5 is less than X is less than 72 inches. is equal to the probability that 0 point something is less than z is less than 3 point something. And I'm trying to find out what that is approximately equal to. So the first step is to calculate the first z-score. So z sub 1 is going to be 64.5 minus 63.6 divided by 2.5. And doing those calculations, that should get me approximately a z-score of 0.36, 0.36. So that matches up with my guess right here. And I can fill it in to this spot. For my second z-score, I'm going to take 72 inches minus 63.6 inches divided by 2.5. And if I find that z-score in my calculator, I'm hoping that it's going to be 3 point something, and I have 3.36. And that also matches up with my guess above. So I'm doing things to spot check myself and stay away from careless mistakes. Okay, I can fill that in up here. In order to find a shaded area, I'm going to use my table, and the first number I'm going to find is going to give me the area from here down, and the second number will give me the area below that cutoff, and that by subtraction I will be able to get the dark blue area. So I'm going to look up 3.36. That's going to be on the back page. 3.3 is down towards the bottom. Well, in fact, it looks like it's not on our table. So I am going to, 3.36 is on our table. Here it is. 3.36 is over to this spot, and it gives me 0.9996. So going back to my problem, I can say that this area is 0.9996. And now I'm going to look up 0.36. So 0.3. And the 6 bar can remain where it is. I get 0.6406. 0.6406. So by subtraction of those two values, I will have my final answer. 0.9996 minus 0.6406. And that final value is going to be approximately 0.359 is the final answer to the question. This can be interpreted as the following. There are only approximately 36% of women who could fit into the Russian spacecraft. So what percentage of women meet that requirement? Approximately 36% of all women would meet the requirement.